Welcome back. Thomas Paul here, 10 plus years tutoring math and science and unlocking student potential. And we got a wordy problem, another potential time waster on the SAT for trigonometry. And we're just going to break it down in the background. We got a triangle, it says, ABC, and the measure of angle B is 90 degrees. They said the side lengths are here. We have another triangle that's similar to ABC, and the vertices DEF are corresponding to ABC. And then it says each side of angle DEF is 1/3 the length of the corresponding side of ABC. What is the value of sine of F? So let's go to the background information we need. What's the background? Each time. So looking at this, it's important to draw. Draw these triangles immediately. So let's draw them up here. ABC is the big one. Let's call this A, B, C. Now it says B is 90 degrees, so you can immediately just begin to fix your triangle like me. Just pretend that triangle doesn't exist. That happens all the time. I'll put B here. No harm, no foul. And next, we got some side lengths. It says here that BC is 32. Okay, remember we're not drawing the scale. And AC is 40. All right, good. Then says we have triangle DEF, and that's going to be similar, so I assume this is going to look like this. There we go. Not drawing the scale, of course. And we'll call that, it says D corresponds to A, and E to B, so we'll just put E there. And that means that E is also a right angle because it corresponds to B. Good to know. Now it says here that DEF, these side lengths are 1/3. Okay, well it's 32. So that's 32 over 3. Not a nice number, but that's the number they're going to give us. And this is going to be 40 over 3. Well, okay. And then next they want to have us here is they want to know, okay, so what's the value of sine of F? And this could be a big waste of time here because a lot of people are going to go and they're going to try to hunt for this because here's our angle F. And that means that if they want the sine of F degrees, we need the opposite value, which is here, over the hypotenuse, which we know. So we know the hypotenuse already. That's going to be 40 over 3. But here's the thing. It's going to be easier to find this value here first. Let me shade it here blue. Because of Pythagorean theorem here. In fact, this corresponds to, if you divide these by a common factor, let's divide it by 8. This corresponds to, that's 5. That's 4. And if you use Pythagorean theorem, 5 squared minus 4 squared is 3 squared. And so if we look at that a little differently, we now just multiply this by 8, so these numbers still apply. This is 40, back to 32. And now this number we now know is 24, using Pythagorean theorem. And so wait a minute, this is 40 over 3. This becomes 32 over 3. This becomes 24 over 3, which is 8. So our opposite value here is just going to be 8. And so we'll clean up sine of F now. Remember that if you're in the denominator of the denominator, the value comes up to the numerator. So sine of F actually equals 3 times 8 over 40. And we're going to cancel that all out. We get, let's cancel our common terms. And so we get sine of F degrees is 3 over 5. We lower that ratio down. And so the key background here, look at all these words meant to waste your time. When you draw the triangle, you can quickly find a way to put the values on it. And then you know that each of the lengths of ABC, we can just divide those by 3 or multiply by 1/3 and find those side lengths in DEF. Now you could have found 24 divided by 3 by using Pythagorean theorem on either triangle. It's up to you. Then you can use your SOHCAHTOA. You have to know that sine is the opposite over the hypotenuse value. And we found it to be 3 over 5 once we cleaned up our mathematics. For Science Math Magic Tutoring. Until next time.